So this is the transfer function given. G of s is equals to 1000 into s plus 1 by s into s plus 2 into s plus 5 into s plus 10. But we have the standard equations as constant. Then we have s 1 by s 1 plus s2 1 by 1 plus s2. So these are the standard forms we are having to solve the problem. So for constant, what is our corner frequency? So for constant, we don't have any corner frequency. For s, we don't have corner frequency. 1 by s also, we don't have any corner frequency. But for 1 plus st, corner frequency is 2. For 1 by st, corner frequency will be 1 by 2. Next, if you are talking about slope, constant has no slope. S has 20. 1 by s is minus 20. 1 plus st is 20. 1 by means in denominator it is minus 20. So this is about the slope. And then when we are talking about phase, constant has no phase. S has 90. 1 by s has minus 90. 1 plus st as tan inverse tau omega. Tan inverse tau omega. And denominator obviously it will be minus tan inverse tau omega. So these are the things you should remember before you start solving Bode plot. So to solve Bode plot, first we should remember this table. Then only we will go ahead. Okay. So now to start with the Bode plot, our standard equations are 1 plus st or s or 1 by 1 plus st. But here if you can see the equation, s plus 1, of course this one we can write it as 1 plus s, so this is fine. And here yes, perfect. S plus 2, no, it should be 1 plus s, means 2 should come out. When 2 comes out, it will be 1 by 2s. Same way 5 come out, 10 come out. So first let us bring it into standard equation format. So equation is given as g of s is equals to, equation is given as 1000 into s plus 1 by s into s plus 2 into s plus 5 into s plus 10, right? So this is the given equation. To bring it into standard equation, here s plus 1 is written as 1 plus s, so it's not a problem. Then s is yes only, but here 2 should come out, then only it will become standard form. So 2 comes out means 1 by 2s plus 1. Then here 5 comes out, so it will be 1 by 5s plus 1. Here 10 comes out, means 1 by 10s plus 1. So this is equals to 1000 into 1 plus s by 2 into 5, 10. 10 into 10, 100. So 100, s is there. So s I wrote, 2 I wrote, 5 I wrote, 10 I wrote. Then 1 by 2s. So 1 by 2s means 1 by 2s will become 0.5, right? Means 1. 1 plus 0.5s. So I brought it into standard equation. Okay. Then this one. 1 by 5s. 1 by 5s can be written as 0.2. So I am writing it in form 0.2s. And this one I am writing it as 1 plus 0.1s. So I just wrote a plus b as b plus a. That's it. Now 100, 1000, if you cancel, 10 is left over. So the equation is 10 into 1 plus s by s into 1 plus 0.5s into 1 plus 0.2s into 1 plus 0.1s. So this is our g of s. So now we brought the standard equation. So this is the given equation. We brought that equation as to our standard format so that it matches our tabular form. So in exam there is no need of writing this tabular form. You should just recollect it. For your clarification I just wrote it. In exam you will write this equation and you will start solving it into the standard form. Once you get the standard form, you will start the solution. So here, what is our equation? It is in the standard form equation. So let me just rewrite the equation. So what we got? G of S is equals to G of S is equals to, we got, is equals to 10 into 1 plus S by S into 1 plus 0.5S into 1 plus 0.2S into 1 plus 0.1S. So this is the equation we got. So when we got this equation, what are we going to do? Now we should start Bode plot. So what is the first step in Bode plot? So the first step in Bode plot is to substitute. First, let S is equals to j omega, because Bode plot is drawn by imaginary values. So we should convert the equation into imaginary equation. So yes, I am substituting with imaginary part j omega. Okay, so S is equals to j omega. So what will be the equation now? Equation will be G of j omega is equals to 10 into 1 plus j omega by j omega into 1 plus 0.5 j omega into 1 plus 0.2 j omega into 1 plus 0.1 j omega. Yes, the first step is done. Okay, now we should find our magnitude plot. So our second step is to find the corner frequencies. For the magnitude plot, first we need corner frequencies. So first let S is equals j omega. Now what are our corner frequencies? So corner frequencies means we should see what are the terms we have, right? So first 10, it's a constant. For constant there is no corner frequency. Next 1 plus S. Yes, it has a corner frequency 2. So in the numerator the first term is 1 plus S. So I will say the corner frequency is 1 because S is multiplied with a 1. So I will write it as corner frequency as 1. Next, then I will go to numerator. I am done. Constant 1 plus ST. I am done. Then denominator I have S or j omega. So denominator I have S. It means 1 by S. 1 by S also there is no corner frequency. Next, 1 by 1 plus 0.5S. Next term is 1 plus 0.5S. So it will be 1 by 1 plus 0.5S. So corner frequency will be what? Corner frequency is 1 by 2. For denominator it is 1 by 2, means S coefficient. So S is having 0.5. So I can write it as 1 by 0.5, which is 1 by 0.5 will be 2. Next, another term is 1 by 1 plus 0.2S. So here the corner frequency will be 1 by 0.2, which is 5. Then another term is 1 by 1 plus 0.1S. Means the corner frequency is 1 by 0.1, which is 10. So now what are my corner frequencies? This is 1, this is 2, this is 3 and this is 4. I have 4 corner frequencies, 1, 2, 5, 10. So the corner frequency should be in a increasing order. So I am naming them as WC1, WC2, WC3, WC4. So these are my 4 corner frequencies. So once I am done with the corner frequencies, the third step I am going to do is slope, to find the change in slope. So to find the change in slope, first I should take what are the terms I am having, then I should check what are the corner frequencies, then I should say what is the original slope, and then I should say what is the change in slope. So first, what are our terms? Our terms are, so first I have 10 by j omega, which is not having any corner frequencies. So I am considering 10 by j omega. So the first one I am taking 10 by j omega. Then I am taking omega c1 is 1 plus s. Then omega c2 1 by 1 plus 0.5s. Next 1 by 1 plus 0.2s. Next 1 by 1 plus 0.1s. Here I don't have corner frequencies. Here the corner frequency is omega c1 is equals to 1, omega c2 is equals to 2, omega c3 is equals to 5, omega c4 is equals to 10. The same values I wrote it here in the tabular form for clarity purpose. Now slope. So again let us consider this table. So here slope, constant has no slope. S is 20, 1 by s is minus 20, 1 plus s is 20. Denominator has negative, numerator has positive. Okay. Now 10 by j omega, right? So 10 by j omega means 1 by s. 1 by s means it is in denominator, so minus 20. This is in numerator 20. This is in denominator minus 20. Denominator minus 20. Denominator minus 20. So these are individual slopes. Now when they are joined together, how the slope is going to be for us? So to say that, we are saying that first our slope is minus 20. So minus 20. Then minus 20 will add to this. So minus 20 plus 20 will be 0. Then 0 will add to this. 0 plus minus 20, which is equals to minus 20. Then minus 20 will add to this. Minus 40. Then minus 40 will add to this. Minus 40 plus minus 20 will be minus 60. So now what is our change in slope? Minus 20, 0, minus 20, minus 40, minus 60. So this is change in slope. Right. Next our third step. We are done with our third step. Now we should go to our fourth step. Now we are saying that we are having corner frequencies, right? So what are our corner frequencies? Omega c1 is equals to 1, omega c2 is equals to 2, omega c3 is equals to 5, omega c4 is equals to 10. So these are our corner frequencies. Now what are we going to do is, we are going to find a lower frequency and an higher frequency. We should imagine something. I am considering it as 0.1 and this as 50. It is completely my choice. If you want to change, you can change, but I am choosing these values. Okay. So I chose less than 1, one value, greater than 10, another value. So now for this, I am going to start my fourth step to find the magnitude. So my next step is to find the magnitude. So what is magnitude? First, at omega is equals to omega L. Means first I am considering omega L as my frequency. Then I will consider omega S, omega C1. Then I will consider omega as omega C2. Then I will consider omega as omega C3. Then I will consider omega as omega C4. Then I will consider omega as omega H. So it means 1, 2, 3, 4, 5, 6. For 6 values, I should find the magnitude. So what is the magnitude formula? So to find the magnitude, our formula is magnitude for omega L is, formula is 20 log constant. First. Second one also, at omega C1 also, formula is 20 log constant. For omega is equals to omega C2, from here formula changes. We say it as slope from C1 to C2, means from top to now. From omega C1 to omega C2 into log of present value by previous value, because highest value by lowest value. Omega C2 by omega C1 plus previous magnitude value. Plus previous magnitude. I am writing the formula again. See, from here all the formulas are same. For omega C3, I am talking about omega C3. So I will write slope from omega C2 to omega C3. I will say slope from omega C2 to omega C3 into log of omega C3 by C2, highest by smallest, plus previous magnitude. Previous magnitude is omega C2. I am writing the formula again. So at omega C4, again what? Slope from C3 to C4, omega C3 to omega C4 into log of omega C4 by omega C3, highest by lowest, plus previous magnitude. Previous magnitude is omega C3. I am writing again omega h. For omega h, it will be slope from C4 to h. Slope from omega C4 to omega h into log of highest value by lowest value, plus previous magnitude omega h. So these are our formulas. All are same. You should understand the concept. When you are talking about this, slope from here to here into log of highest by lowest plus previous magnitude. Same way everything. Okay. First two will be 20 log constant. So what is our constant here? What is our constant? Our constant is 10 by j omega, because this is a term. Everything is having corner frequency. Without corner frequency is our constant, means 10 by j omega, means 10 by omega. So 10 by omega. What is omega here? Omega L. So means 10 by omega L, which is equals to 20 log of 10 by, what is omega L I considered? I considered it as 0.1. So if you calculate this, you are going to get 40 decibels. Same way, this one, 20 log constant. Constant means 10 by omega C1, which is equals to 20 log 10 by C1 is 1, which is equals to 20 decibel. Now here, this is equals to, what is this saying? Slope from C1 to C2, means slope from C1. So at C1, what is our slope? 0 is our slope, right? So at C1, omega C1, slope is 0. So I am using the same. So slope is 0 into log of omega C2. What is our omega C2? 2. Omega C1 is 1. Plus previous value is 20, right? Our previous value is how much? 20. So 0 into something will be 0. So answer will be 20 decibel. Now here, slope from omega C2. From omega C2, what is our slope? Minus 20. So minus 20 log C3 is 5, C2 is 2. Plus our previous value is 20. So if you calculate this, you are going to get 12.04 decibel. Next here, slope from C3. From C3, what is the slope? Minus 40. So minus 40 log of omega C4. Omega C4 is 10 and C3 is 5. Plus previous is 12.04. If you calculate this, you are going to get 0 decibel. Then here, slope from C4. Slope from C4 is minus 60. So minus 60 log H. Omega H. Omega H is 50. That is what we considered. So omega C4 is 10. Plus previous magnitude is 0. If you do this, you are going to get 41.9. Sorry, minus 41.9 decibel. So this is how you calculate the magnitude. So for omega L, it is 40. For omega C1, it is 20. C2 is 20. C3 is 12.04. C4 is 0. And omega H is minus 41.9. Okay, we are done with the magnitude. Okay, next. So then we are going for the fifth step. Our fifth step is to find the phase. So to find the phase. So to find the phase, let us go back to our first table which we thought to remember while doing this problem. So let me bring that. So this is our phase. So according to phase, S means 90. Constant, there is no phase. 1 by S is minus 90. 1 plus ST is minus tan inverse tau omega, means coefficient omega. If it is denominator, it will be minus tan inverse tau omega, right? So by using the same thing, we are going to do the problem. So here, according to our equation. So this is our final equation which we got, right? So from this equation, let me write the phase formula. So phase. So phase phi is equals to, what is our phase? First 10. It's a constant. Constant has no phase. Then 1 plus ST. 1 plus ST means what it is? Tan inverse tau omega. Tau means coefficient. Coefficient is 1. So it will be tan inverse omega. Next, everything is in denominator. So obviously it will be negative. S means 90. 1 by S means minus 90. Then this is also in denominator. So I will say minus. It is 1 plus 0.5S means minus tan inverse 0.5 omega. Next one, minus tan inverse 0.2 omega. Minus tan inverse 0.1 omega. So this is our final phase equation. Now, what are our frequencies? Our frequencies are omega L is 0.1. Then we have 1, 2, 5 and 10. These are our frequencies, right? Next, we should find tan inverse omega. Then just write down minus 90. Then find minus tan inverse 0.5 omega. Then find minus tan inverse 0.2 omega. Then find minus tan inverse 0.1 omega. So just create a table like this. Easy way of calculating phase. People who are fast at using calculator, if you are very comfortable, 0.1 is the omega value. So 0.1. Take calculator, type tan inverse of 0.1 minus 90 minus tan inverse of 0.5 into 0.1 minus tan inverse 0.2 into 0.1 minus tan inverse 0.1 into 0.1. Find the answer. If you are good at using calculator, if you are good at mathematics, you can directly do. But people who are slow, it's better you take the terms. How many terms we have? 1, 2, 3, 4, 5. 5 terms, I took 5 columns. So everything use with the signs. So no need of looking back. Okay. So now what is the best way to do? We need is phase, right? So first 0.1. Find tan inverse 0.1. Tan inverse of 0.1. So use your what we say calculator and find tan inverse 0.1. So it will be 5.7. Then this is minus 90. Write it as minus 90. Then tan inverse 0.5 is 2.86, but I am talking about minus, so I will say minus 2.86. Then this is 1.14, so minus 1.14. Tan inverse 0.1 into 0.1 is minus 0.57, so I will write it as minus 0.57. Now in the calculator say 5.7 minus 90 minus 2.86 minus 1.17 minus 0.57. You will get minus 88.87 something. So let it be minus 88. Same way, tan inverse 1. Tan inverse 1 is 45. Minus 90, write it down. Then tan inverse 0.5 into 1. So tan inverse 0.5 into 1 is 26.56. I am writing it as minus 26.56. So signs also I am following so that I am not looking back. So this will be minus 11.3. This will be minus 5.7. So if I add all this, I am going to get again minus 88. Then again tan inverse 2. So tan inverse 2 is 63.4 minus 90. Then tan inverse 0.5 into 2 with the minus. It is 21, it is 45. So I am saying it as minus 45. And this is 21.8. I am saying it as minus 21.8. And this value is 11.3. So minus 11.3. Now add all these values. So you are going to get minus 104.7. Okay. So this way, if you do, it will be easy without any mistakes. Okay. So if you do all these values, tan inverse 5, we are going to get 78.6. This is 84.2. This is minus 90, because in formula we are having minus 90. I am writing the minus 90 same, so that we are not doing any mistakes. Okay, that's why I don't want to create any problems. So minus this is 68.19, this is minus 45, this is minus 26.56, this is minus 78.6, minus 63.4, minus 45. Sorry, we have 50 also, right? So for 50 also, I'm going to get 88.8 minus 90, minus 87.7, minus 84.2, minus 78.6. So if I add all this, I'm going to get minus 251.7. Here I'm going to get minus 192.8. Here I'm going to get minus 151.15. So this is the phase tabular form. So by using this way, you will do less mistakes. Mostly you can't do mistakes. So for these frequencies, these are your phase values. Okay. So finally, what are our frequencies? 0.1, 1, 2, 5, 10, 50. What is the magnitude values we got? For magnitude means A. For magnitude, what we got? We got is, let me just check, 40, 20, 20, 12.04, 0, minus 41.9. These are the values we got. And for phase, what we got? These are the values. I am writing them again. Minus 88, minus 88, minus 10.04.7, minus 151.15, minus 192.8, minus 251.7. So these are our values. So this is our final solution. Okay. So for this, we are supposed to trace the Bode plot. Okay. So I don't have an empty graph, but this is the graph I have sent you in what. This is the graph I'm going to share with you. You can check here. So this is how a Bode plot will be, right? So broad line should be starting the graph. Small length should be, small distance should be at the corner. Okay. So if you are taking the graph like this, it is totally wrong. Okay. So you should be very careful while taking the graph. Your graph should start with a broad length. So now, so we are having our frequencies, right? So according to our frequencies values, what are our values? We have 0.1, 1, 2, 5, 10, 50. So in this graph, the flexibility is we can choose what are the values we have. So our frequencies are this: WL, C1, C2, C3, C4, WH. So I wrote as it is. Now for 0.1, what is the value we got for 0.1? We got 40, right? For 0.1 it is 40. So here it should be even on this side, but on the top side, it can be according to our values. So here I took even, so it is 40, so I kept it as 20, 0, because it started with 40. So that's the reason I started with 40, and I can see there is a difference of 20, so I thought let it be 20. So that's the reason, but if you want to change, it's up to you. So 40, 20, 0, minus 20, minus 40, minus 60. So for 0.1 it is 40, so I dotted here. Then for 1 it is 20, then for 2 it is 20, then for 5 it is 12.04. 12.05, how to calculate, you know them, right? The distance is 20, and the scaling we have 5 divisions. So 20 divided by 5 division is 4. So each distance is 4. So from here you should check. This is 0 means this is 4, 8, 12. So that is the reason we kept 12 as the knot. Okay. Then for 10 it is 0. So at 0 we kept. Then again at 50 it is minus 41. So this is minus 40. So you wrote it as minus 41 little down. So now this is the magnitude. The black graph is our magnitude graph. So magnitude slope, if you remember, here you can see what is our slope saying. Our slope is saying first the graph should go minus 20 down. Yes, if you can see, first the graph is gone minus 20 down. Perfect. Then it should be 0. Yes, it is 0. Then again it should go minus 20 down. Yes. Then again it should go minus 40 down. Then again it should go minus 60 down. So these things is exactly the same. It means verification is also done. Your graph is perfect. Then phase. For phase we are having minus 88 and minus 251. So minus 250 means always I prefer 30 degrees. So I took 30 degrees difference, and this side I am noting the values. Minus 270, minus 240, minus 210. So that it will be easy to draw. So that there are no confusions. Because again if you take the values this here, they might overlap. So that's the reason we noted this side. But compare, what we say, consideration will be this side only. Just noting this side. So 270, 240, minus 210, minus 180, minus 150, minus 120, minus 90, minus 60 with 30 degrees difference. I prefer like that. Okay. So now for 0.1, what is it? 88. So at 0.1, it should be 88. So here it is 90. Distances 30. So 30 divided by 5, because divisions are 5. So as the divisions are 5, 30 divided by 5 will be 6. So each is 6. This is 6 means 66, 72, 78, 84 something. Yes, right, 84. So 84. We have 88. So we draw it in between. The red line you can see 88. Then again it is 88. Then minus 1.04. Then minus 151, minus 192, minus 251. So according to this. Then we are using a rough scale. For magnitude you should use a scale properly. For phase you can just use your free hand to join it. We are done tracing the graph. Once the graph is done tracing, what are we going to do? We are going to find the phase margin. We are talking about a phase. So when I am talking about phase, I will consider the magnitude 0. So you can see the blue dotted line. At 0, sorry, the green dotted line. At 0, I am saying 0 is touching here. This point is going down. I am keeping a scale. The green is like a scale. I kept a scale here. So it is touching here. Now I kept the scale in horizontal position. Now when I check, it is touching the phase plot here. So what is that value? It is here. Means 188 means this is 186. Then 192. Okay, this is 192. Okay, so I wrote it as 192. So what is phase margin? 180 plus what is the value you got? I got is 190 minus 192. So I wrote 180 plus minus 192, which is minus 12.8. Then gain margin. Gain margin means I will consider minus 180. Minus 180 I am tracing. I am going where it is touching the magnitude, and I am checking what is the value it touched. It touched it at middle. So usually the distance is 4. As it touched at the middle, I am saying it as 2 plus 2. But gain margin is minus of what you get. So minus of 2 I got, means negative. So this is minus 12.8, this is minus 2. Both are negative. So I will say system is unstable. 1 positive, 1 negative, unstable. 1 negative, 1 positive, unstable. Both are positive, then only system is stable. When both the systems are positive, then only we can say that the system is stable. Any one positive or negative, we can simply say system is unstable. So this is Bode plot. So what are we going to do first? First, actually, of course, usually what we do is we are checking the question here. Actually, here the question is not given in a proper format. So it is given like this. So first we converted it into proper format. Once we got the proper format, keeping this table in mind, we started our solution. So first is S is equals to j omega. So substitute S is equals to j omega. Then corner frequencies with the tabular form. Then slope. So S is equals to j omega. Corner frequency is the slope. Then magnitude we should find with the red formulas you should remember. Then we are finding the phase. So we should find the phase like this. So once we got the phase, magnitude and phase, these are the values. We will take a Bode graph and we will plot the graph. So once we plot the graph, we will say what is phase margin. To find phase margin, 0 is touching at which phase value, minus 180 is touching at which magnitude value, reverse of it. Okay. So this tricky thing, when you are talking about phase, we are talking about 0 magnitude. 0 is touching at which angle. When you are talking about gain, minus 180 is touching at which magnitude value. So both should be positive. If anything is negative, we will say system is unstable. So this is Bode plot.